Okay, so this is a recording for the lesson 2-3, solving factored equations. And this equation, I'm going to be using the Casio calculator. This is the one that if you've gotten a calculator from school, you have this one. And I have two ladies here with me today, and you guys feel free to jump in with your questions. This, let me just say a little something, because this particular lesson, it has some little parts to build up. That when we get finally to the meat of it, it's kind of a simple little trick. But I want to do more than just show you the trick. I want to take just a few minutes to show you why this trick works, and to do that, I'm gonna explain like a few little parts, and they're gonna feel separate, but then it's all gonna come together in learning this little trick that works with quadratics. So let me go back to the camera, and you guys jump in if you have any questions. And so we're gonna go back to the document. And so go ahead. What the goal of this lesson is to recognize the relationship between a quadratic equation that's written in factored form. So here's the quadratic equation that we've been working with: x squared minus 2x minus 3. Where this is called standard form. And we've been working with quadratics, and a lot of times we do that in standard form, which means we're working with it when it says ax squared plus bx plus c. So this is ax squared plus bx plus c. A is 1, b is -2, and c is -3. But for today, for this lesson, we're going to work with this one that you can see the parentheses. This is called factored form. And the parentheses are touching each other. There's two sets of parentheses. Now sometimes there's a number in front here, and we're going to figure out what to do if there's a number in front here. But we're going to look at the relationship between this equation in this form, this graph, and the zeros. And there's a very cool little relationship. So this relationship. So let's look at this graph and find where are the zeros. I'll make it bigger, see if we can find.
-4.
Well, -4 is way over here, so it's not -4.
Okay. Zeros.
So we're always looking for those that cross the x-axis. So I'm going to go to the x-axis.
-1.
Yes, there's it. -1.
2, 3.
And 3. Now, when I write those, let me just review this. Do I put parentheses here?
I want to say no.
No is correct, because you only put parentheses if the first was an x and the second one is a y. And these are both x's, so we're not going to use parentheses. If you do anything, you put those swirly ones. You don't have to put them, but if you're going to put them in something, you put them in the swirly ones. But that's just review. Now I want you to just take a minute and look at. So we got these numbers, the -1 and the 3, by just tracing the x-axis with my mind and finding where it intercepts the x-axis, because these are also called the x-intercepts. Now I want you to look at these numbers and the factored form and see if you notice any patterns. You notice any relationship, anything, how these might be related to each other.
It's the opposite.
Yes.
It's -1 is 1, -3 is 3. Yeah.
Yes. Here, this is negative. Inside is positive. Here, this is positive. Inside, it's negative. Now, these are called the zeros or the roots or the solutions. And these are the factors every time the parentheses. And the big thing is here that they are opposites. And this is the trick that I'm gonna teach you how to work with. It's such an interesting trick. Let me kind of move out for a little bit. That it's worth pointing out. It's an easy one to learn, I think, and that's the point of this lesson. I'm going to teach you the opposite trick. It works a lot of the times. It doesn't work all of the times, but it works a lot. And so also what I want to do in the next, say, 5 or 10 minutes is that you know when it works and when it doesn't work. So we're going to talk about this opposite trick, and this is part 1. Now I'm going to shift gears and I'm going to talk about something else. Do you need a minute to write this down?
No, I'm fine.
Okay. And you know, if anyone's writing it down, you just pause your video and then you can continue. So now I'm gonna this is kind of separate for a minute, then it's all going to get put together later, but I'm going to ask you a separate question. We can use this relationship to help solve quadratic equations. So let's pause for a minute. What does it mean to solve a quadratic? And so I just want to pause and think about, what does this word mean, solve? And solve is the verb that goes with the noun solutions. And what are the solutions of a quadratic? Now remember, we did this earlier. We kind of, we didn't review on that one, sorry. Let me go back here. Now we worked with this one, and depending on which notes you did, these here have 4 names. They're called the zeros, they're called the roots, they're called the x-intercepts, and they're also called the solutions. So anytime they ask for the solutions or the x-intercepts or the roots or the zeros, we're looking for the same 2 points. So what we're looking for are here. The roots or the zeros. We're looking for these points. If it says solve a quadratic, solve comes from the same word as solution. This is the noun that goes with this verb. And so that's what we're looking for. So if we want to solve this, we're looking for these 2 points. So here I am, I'm gonna switch gears and I'm gonna ask a new question. So we've got this opposite trick. We've talked about what solve is. And now I just want to give you a number riddle. So here's my number riddle. If I have 2 numbers, A and B, and I multiply them, I multiply my 2 mystery numbers to get 0. What do you know about my numbers?
They're the same.
They're the same, like 3 and 3? Like 3 times 3 is 0? No?
No. The number most likely is probably 0.
Yes.
Yeah. Like, how do you get 0? You'd have to, what's going to be true, if you multiply and the answer is 0, what has to be true? Either A has got to be equal to 0 or B has got to be equal to 0. if I multiply this and get 0, one of them is going to be 0.
Right.
And that's the only way that's going to work. So again, what I want to do for a minute, we're going to use this little trick to solve this equation. Now, this particular equation has, it's written 2 different ways. The first one is standard form, x squared minus 2x equals 0. And then I factored it. And I want you to focus on here where it's the factored form. That's where we're working from. Now, like I said, I told you what this question is, this lesson is about. What we're doing is looking at the relationship between the zeros and the factored form. What we're not doing just today is I'm not really showing you how to factor in the standard way. I will show you kind of a backdoor way to do the factors by finding the solutions. But later on in another course, you'll practice more about how to get from the standard form to the factored form. So that's what we're not doing today, but I am going to give this to you and we're going to learn how to work with it. So what I have basically here is I have 2 different numbers represented by x and x minus 2, and it's equal to 0. So in order to do this, here is the method that we're going to use. It's called split and solve. What I'm going to do is split this apart, and either this number that's in the front, which is x, is equal to 0, or this part that's represented in parentheses is equal to 0. So if you have 2 things equal to 0, we can split it and find out where it's 0. Or there's 2 possible answers. So the first part, when I take the x off to the front, it's really already solved. There's nothing more to do with this one. It's just finished. But for here, I do need to do a little bit of work. If I look at the x, and there has a minus 2 next to it, how do I get just the x by itself? What I want to do is get rid of this minus 2. What's going to get rid of a minus?
Plus 2?
Yeah, so I'm going to go plus 2 plus 2. Now this minus 2 plus 2 cancels out, and I just get x. And here, 0 plus 2 is 2. And now I have my second answer. So I have 2 possible solutions, 0 and 2. And just put this in context here, because we're going to do a little graph, but we're not going to do the full graph like we just did before. I'm just going to graph here. So here's 0 and here's 2. Now for this graph, I'm just going to sketch it. It's not, on purpose, I didn't put all the lines here, but you could still do a sketch if there's lines. We're just, what I don't know, and I'm going to use a pencil so I can erase it, is I don't know if this graph, maybe it goes up, maybe it goes down. Maybe it goes really wide, like that. Or maybe it comes really skinny, it comes high and goes down and low. Because I don't know at this point where the vertex is. And for today, we don't matter. It doesn't matter where the vertex is. We're just going to worry about these points, the roots or the zeros, because these are the solutions. This is how we solve it. So sometimes we don't need that vertex. So the thing is, what I want to do here is just, the biggest decision is whether to go make it open up or make it open down. Now, it wasn't an earlier video that you watched, but how do I know whether this one opens up or opens down?
Because it's not a negative.
Yes, we're going to look right here. This is where you look, is at the front of the x squared. And if it's blank, that means it's positive, and positive is our happy face. So this one opens up. Now again, I don't know how far it goes down. It's just a sketch of the graph. But I want to make sure it hits my 2 zeros that I found. I found 0 and 2. I took this and split it into 2 parts and solved it. So let me tell you a little bit about split and solve. Split and solve always works. If you've got the right factored form, this will always work. The opposite trick works sometimes. So when the opposite trick doesn't work, you can use split and solve. So we're going to practice this one here. Well, let's look for a minute at the opposite trick. Look for a minute at this one here, at the 2 and the factor. Is this opposite?
No. Was -2 and 2, yes.
Yeah, it actually is. So the opposite trick could work here. If I see x minus 2, I can look at the -2 and pull this one. And really, when you see an x all by itself in front, then it's going to be 0.
Okay.
If you practice, you'll be able to solve this one without doing split and solve. You can go, oh, there's an x in front by itself, so that's a 0. That's a -2, so this is a +2. So again, within 5 or 10 minutes, you'll be able to do this one without doing this part. But we're going to practice this because this one will always, always work. So if you're ready, you guys ready? I'm going to turn the page. Now that we've got all the little parts, we're going to look through and just really practice it with these 3 examples. So here's the first example. And now I've said that the opposite trick works most of the time. It works a lot. So we're going to decide when we're going to work through when does it work and when does it not work. So let's say the opposite trick does work on this one. Let's just pretend like it does work. Then what would the answers be?
The answers will be positive. Will it be 3, -4?
Yeah, no, and actually the opposite trick does work on this one, and these are the answers. They're it. I can go over here to the 3, and there's my solution here, and I can go to the -4, and there's a solution there. And then to do the sketch, I would just decide is the happy or sad one. So is this one open up or open down?
It's opened up.
Yeah.
Open down because it's negative.
Again, what I'm doing is I'm looking right here, and this is positive. The x squared, the coefficient, or it's invisible. It's an invisible 1. If it's positive, then it opens up. Now we kind of like have this silly thing, positive things are happy, and so it's a smiley face. But what I want to do is go ahead and use the split, and really you're finished. But I'm going to use the split and solve to just prove that these are the answers and to check that they are. So if we're going to go ahead and practice this because we've only done it once. But let's practice the split and solve. So I'm going to take this part and this part and break them apart. So this parentheses says x minus 3. And so maybe this one is equal to 0. And this one says x plus 4. So maybe this one is equal to 0. I have two things being multiplied. Each one is in parentheses, and it's equal to 0. Now again, for right now, we're just focusing on the factored form. This is where it comes from, and you'll learn later how to get from here to here. But so this one, if I solve this one, there's the x. What am I going to add to that -3?
+3.
Plus 3.
+3 plus 3. And so x equals 3. Yep, that's the one I had. What do you put with a +4?
-4.
Negative.
Yeah, so I'm going to go -4, -4. And these cancel, and I get -4, which is what I had. So this is going to work. You can always use this, but just to know that there is this opposite trick that just makes things go quick if you practice it a little bit. So I want to look at a different one. And so the next example, it has a little bit different. And again, focus on this part that is the factored form. Now let's say the opposite trick works. And what are the solutions?
The solution would be -5 and -2.
-2.
Right. Now, what might be confusing is this -6 in the front. But the
Yes.
solutions are only going to come from the places where you see the x. Now, this one does not affect the zeros at all.
Okay.
And in this case, if all you're doing is looking at this equation to find the zeros or find the roots, then you can ignore this for right now. Notice this one is different. What's in front is an x. And where you see an x, that means you've got a solution. So the x, if it's all by itself in front, that's how we got the 0. But this one with the -6 does not give us any solutions. The solutions come from where the x's are. So these are the zeros. Now for this one, I have to it only goes to -4, so I have to draw in one more space to get the -5. And there's the -2. Now the question is this one open up or open down?
It's down, sideways.
Why is it down? Yes.
Because it's -6 in the beginning.
Yeah, this one we see a negative in the front, so it means things are looking down. Now again, I don't know how far up it goes or how far down, if it it goes real skinny. I don't know where the vertex is, but it is going to go somehow, opens down between these 2 points.
Mm-hmm.
And again, what we're doing is we're sketching a possible graph. It's different than what we did at the beginning when I did the do now, where we found all the exact points. And I'm going for that piece of paper. We did this one. Now this one we want to be very exact. We're finding all the points. We've got the equation, and we went to the calculator and we found everything and we mapped it out. So this is a very precise graph. This is just a sketch of a graph. Sometimes you need to be precise. Sometimes you don't. Okay, so we used the opposite trick and it worked on this one. We use the opposite trick on this one. Can we use the opposite trick here?
It looks kind of tricky because there's not a X or anything or a number before the.
Yeah, that's the big difference. We can't use the opposite trick. And the reason is the difference, I think, Loretta, you're kind of pointing it out, is if you look here in the parentheses, this one starts with an X, this one starts with an X, this one starts with an X, and this one starts with an X. The difference is here that the X has a coefficient other than the invisible 1. So because there's a number, a coefficient next to the X, we're going to have to use, this is when you have to use the split and solve. I'm going to take these parts. So I'm going to take the first one, 2x minus 4, and 3x plus 5. And I'm going to split them into 2 parts that are equal to 0. And now I'm going to solve. So let's see. Let's solve this one. What would we got 2 steps to do. What's the first thing?
So you would have to add 4.
Yeah, you look for the add subtract thing.
Well,
Okay, so it'll be 2x equals 4. And then that'd be the same thing.
divided by 2.
Yes.
Yeah. Now we're going to divide by 2. So I found the first one. So there's one of the solutions. And I'm going to go ahead and put that one on the graph at 2. Now go ahead and see if you can solve this one.
-5.
And we're going to go -5. I like using the colors here.
What baby?
It's not broken anymore.
Okay.
But it was divided by 3. X equal 3.
Now, a lot of times this answer is sufficient. The trouble is it's hard to graph. And so what we usually do when we see mixed improper fractions or fractions at all is I'm going to go ahead and divide that out. Now on this calculator, I go to menu 1 to get the regular one, and I know it's going to be negative. I usually don't type that in because I just know whatever it is, it's going to be negative. I'm just going to go 5 divided by 3.
It's 1.6.
And it's 1.66666. Now I've rounded it here. That if I round it to the 10th place, then that's going to round to 1.7 because I don't want to write all of that. So I chose to round it to the 10th place there. Now the key is, where is this between?
It's in between the -1 and the -2.
Yeah.
Closer to the -2 than the -1.
Exactly. But you're going to look, really just find the place where it's in between. And there's one last thing I have to decide now, and that's whether this one opens up or opens down.
It opens up, the happy face.
We're going to look again.
Oh, well.
Yeah.
It's not.
And we're not being very specific. We just want to make sure it opens up and then it goes through these 2 points. Now there's a little bit of practice here, and I just want to show you on the next page where that goes. But basically, let's review. If the x is, like the coefficient of this x is an invisible 1, an invisible 1. So if you see a plain x, you can just do the opposite trick. If you see something in front, you're going to have to do the split and solve. Now, sometimes you'll get one that you have to split and another one that you might be able to just work in your brain. Well, I didn't write these up. By doing the opposite trick. And there's this little trick here that if the x is by itself, then you get the answer 0. Now what this means is that I can start from any place. I can start with an equation in factored form. I can start with the zeros, or I can start with a graph and I can find the other two. So this is the one we've been working with. We're going to start with an equation, come up with the zeros, and then we're going to just do a sketch of a graph. So can I use the, what does this mean when the x is by itself?
It's 0.
The 0 is 0. And what's for the second part?
Where I got into detention for no reason.
5.
Positive 5.
Yeah, and really that's all you need to do for this one. There's 0. Now before I just call this 5 over here, make sure you do, when you do a sketch of a graph, that you tell me something about this line. 1, 2, 3, 4. You can either put the hash marks, the little dividers, or you can put the number. But don't just put something like this without telling me. Now the question is this one open up or open down?
Open up.
Yeah, I'm gonna look back over here, and this one opens up.
Up.
That one's finished.
In elementary school, I got into detention for no reason.
Mm-hmm.
I got into detention for no reason.
Now,
Do you know why?
what I'm gonna do is I'm gonna work backwards, because we've been practicing how to go from the factored form to the zeros, but actually, once you know this trick, you can work backwards. So if these are the answers,
Teacher. Or
what was in the parentheses?
I didn't do anything.
Positive
4.
Yes.
So I'm gonna put it like this. X plus 4.
Plus 4.
And what about the second one?
X minus 7.
Yes. Now, this should be written in equation. So you have a couple of choices. You could write the answer with y equals. You could write it with f of x equals. Or you could not put those and put equals 0 with this one. So let's just, this one is going to be rewritten like this, but you can see you could put equals 0. They're all kind of interchangeable. What I want to do now is to go ahead and 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7.
It's -4, up and down.
Well, the way I've written it
Okay, positive.
is positive.
Yeah.
So these need to match.
Okay.
But actually, it could have a negative here.
Okay.
And if it had a negative there, it would go this way.
Okay.
So this would also be a correct answer. We usually just kind of, if you're going to write one answer, a possible answer, the positive one, but really both answers are correct. But whatever this is should match this one. So if this is a positive one, this should be a positive one. If this is a negative one, this should be a negative one. Now this one was printed, so there's only one way it can be. This one can only be a positive one. This one can only be a positive one. So now we're going to start with the graph. Let's see if we can get to the factored form, but first let's find out what are the roots. And again, these have two names, roots or zeros, solutions. So what do we see from this picture?
I think
1.
it's, yeah, 1 and
1, 4. 2, 3, 3.
1 and 3.
Yeah, 1 and 3. Now don't put parentheses because these are two different ones. Now, what goes into the factors? The factors have parentheses.
X, -1.
x negative 3.
Yes. Now I have options. I can put y equals at the front, or
Or
this one
equals
I'm going to
0.
be different. I'm going to put equals 0. That's kind of it. What do you ladies want to stay and do the next two for practice with me right now?
Yes.
Yes.
Okay. Now I'm gonna pause the recording, but I'm gonna give you two. Yeah. Now you said minus negative, but we're just gonna say x minus a half because this one's positive, so I'll make sure there's just one negative. And let's see, Maria, what's in the second parentheses?
Positive 1.
Yeah, I'm gonna say x plus
X
1.
plus 1.
Yeah. Now you could write it two ways. You could put the y equals, or you can put
Y
over here equals 0. You wouldn't put both y equals and equals 0, but put one or the other. And this is correct. I will count this correct on the test. But I want to show you what this is also equal to. These are the same equations.
Okay.
And I can prove it to you by, I can take this one here. Now this one is, if I do the opposite, this is +1, so it's -1. But for this one, I'm gonna have to do split. I'm gonna have to split it off and solve it. So I'm gonna prove that this is the same thing. So I'm gonna,
Okay. Positive 1. Plus.
yeah, +1, then that eliminates the 1, and then the 2x comes down, 0 + 1, and then
Divided.
divided by 2. And so what do I get? X equals 1/2. So just that you won't usually see a fraction inside of a factored form. Now, if you get really fancy, this 2, that's the denominator, comes around to the front. And so the 2 is here, 2x minus 1. And that's a really more advanced trick, but just know that really more than anything, this is going to be counted correct. If you write x minus 1/2, I'm going to count it correct. But if you saw this also in a STAR test, you're going to see this 2x minus 1. Let's just real quickly review how to graph that one. Well, I know how to graph -1. It's over here. Now, where is 1/2?
It's in between the 0 and the negative.
Yeah, and I kind of made the space big on purpose so I could get that because I knew it was coming. But -1 is there, and so this one is in the in-between. Opens up or opens down?
It opens
up.
Yeah. Now, and again, that's just because of the way we wrote it.
Mm-hmm.
I could just as easily have put a negative out here and it would still work. This would still be a correct answer. So this is one correct answer. Well, it's actually 2 different correct answers, but there's even more. And because I could still get the same solutions, is this open down? So that's basically what the next practice page is. Then it kind of separates off. There's a more advanced kind. So here's where I would do the next page. And then pause. What I'm going to do is go ahead and explain this one here. But if we were in class, and it's getting close to time, so I'm going to go ahead and explain this one right here. Now on your papers, it might look a little different, but there are some that look like this, because this one has got a special one. Now let's look at this one real quick. Now what I'm trying to find the zeros or the roots, same thing. And then we're going to sketch a little graph. Let's look at the first parentheses. Can I use the opposite trick here?
X -3.
Yep. What about here?
X negative, positive 5. No,
No.
Well,
no.
it's the 2x, so you can't.
Yeah, so what I have to do here is I need to make a little equation.
Okay.
So this one, I can't use the opposite trick because of the 2. It's blocking it. So I'm gonna have to go ahead and solve this one out.
So it's
Positive.
negative, positive.
Plus 5. I'm going to go ahead and divide that out because I end up with this 5 over 2, or 5 divided by 2,
1.5.
2.5.
2.5.
You should get, you divide that, you should get 2.5. I'm going to go 5 divided by 2. And so 1, 2, 3. 1, 2, 3. So -3 is right on the -3. Where is 2.5?
In between.
In between
negative
is 2 and 3.
Yeah, it's an in-between one. And does this one open up or open down?
Up.
So-
Up and down. No, up.
Now I want to look at
Well, no,
both.
because it's
No,
negative.
because the first time is positive.
You want to look at the x's. This x is positive and this x is positive. So positive, positive, and these are being multiplied. And that's going to be the trick here on this one. So what are the roots for this one? What looks funny about that first one? There's something
It's,
unusual about
the 3 is,
yeah, what I think about this one is that it's backwards.
yeah, that's the word I was looking for, backwards.
When you see one that's backwards, like this is 3 minus x is a shorter way to write negative x minus 3.
Mhm.
So what this means, if you see one that's backwards, is that you're going to have a negative, and negative means this one, so this one's going to go upside down. Now, what is the opposite here? Oh, you can't see that.
Oh, come on, where we at?
Yeah, sorry.
You change it.
Okay.
Yeah, so this one is another way to say x.
-3.
Yeah, this one stays the same, but this one is this is another way to, 3 minus x is just a shorter way to say negative x minus 3. So what are the roots?
-3.
Well, I'm going to use the opposite, so that's going to be
Opposite.
a 3.
Positive 3, positive 5.
So I've got, this is 3 and 5. And does this open up or
It's
open down?
down.
Yeah. So there's that little, yeah, you just have to watch for this backwards trick. But there's sometimes you'll see one of these that it's backwards. So watch out for those. So I'm gonna go ahead and close this recording.